Tonight, we are going on a journey together. Not a journey that requires you to move or to do anything at all. Simply a journey of listening, of imagining, of allowing your mind to drift along with the oldest story on Earth, the story of water. Water flows. This is perhaps the simplest, most fundamental truth of our planet. Water flows downward, pulled by gravity, seeking always the lowest place, the path of least resistance. And in flowing, water shapes everything. It carves mountains into valleys. It carries nutrients across continents. It connects the highest peaks to the deepest oceans. Water flows, and in flowing, creates the conditions for life itself. But there is another place where rivers flow, another landscape carved by moving currents. This landscape is hidden, protected within bone, cushioned and surrounded by fluid. This landscape is your brain. You might wonder, what do rivers have to do with the brain? What connects the mighty Amazon, flowing through jungles, to the soft, folded tissue inside your skull? The answer is more profound than you might imagine. Your brain floats in fluid, suspended like an island in a gentle sea. This fluid flows, circulates, refreshes itself constantly. Your brain is fed by rivers of blood, channels that branch and divide like tributaries, reaching every cell. And within your brain tissue itself, between the cells, fluid moves and circulates, washing away waste, delivering nutrients, maintaining the precise chemical balance that thought requires. The ancient Greeks believed that thoughts flowed like water through the brain. They were wrong about the details. They thought the brain was a cooling organ for the blood, not the seat of consciousness, but they were right about the flowing. Everything in your brain that allows you to think, to feel, to remember, to dream, all of it depends on flow. Flow of fluids. Flow of electrical signals. Flow of chemical messages from cell to cell. Rivers have been sacred to humans throughout our history. We have worshipped them, settled beside them, drawn them in our earliest art. Cave paintings from 30,000 years ago show rivers, show the zigzag lines of flowing water. Why? Because we knew, we have always known, that water is life. Where water flows, life flourishes. Where water stops, life struggles. Perhaps we sensed, even then, that we carry rivers within us. That we are, in a very real sense, made of flowing water. Your body is roughly 60% water by weight. Your brain is even more, about 73% water. Every cell in your body is a tiny ocean, and these oceans are connected by rivers and streams, by blood vessels and lymphatic channels in the spaces between cells where fluid moves. Tonight, as you rest here, as you let go of the day's concerns and allow sleep to approach, your brain's rivers are flowing. Right now, in this very moment, cerebrospinal fluid is circulating around your brain and down your spinal cord, making its gentle rounds. Blood is pulsing through hundreds of miles of vessels in your skull, bringing oxygen and glucose, carrying away carbon dioxide and waste. Between your neurons, in spaces so small they can barely be seen with the most powerful microscopes, fluid is flowing, participating in the constant chemical conversation that is your mind. You don't have to do anything to make this happen. You don't have to remember to circulate your cerebrospinal fluid any more than a river has to remember to flow. It simply happens, as natural as breathing, as automatic as the beating of your heart. Your brain knows its ancient work. It has been doing this work since before you were born, since you were a tiny cluster of cells in your mother's womb, and it will continue until your last moment. There is something deeply comforting in this, isn't there? That beneath all our worries, beneath our plans and memories and hopes and fears, there are these fundamental processes, these rivers that simply flow. They don't doubt. They don't hesitate. They don't wonder if they're flowing correctly. They just flow, following laws older than consciousness, older than life itself. In the story we're about to explore together, we will follow a river from its source high in the mountains all the way to the sea. And as we follow this river's journey, we will discover how it mirrors the rivers within your mind. We will learn how both kinds of rivers nourish and protect, how both kinds of rivers shape the landscapes through which they flow, how both kinds of rivers are essential, irreplaceable, worthy of wonder. But this is not a lecture. You don't need to remember any of this. You don't need to stay alert, to take notes, to prepare for a test. In fact, the opposite is true. Let yourself drift. If your attention wanders, let it wander. If you find yourself thinking about something else, that's perfectly fine. If you fall asleep before the story ends, that's not a failure. That's exactly what we hope for. This story will be here, flowing like a river, whether you're listening closely or drifting away. The facts we'll encounter are real. The science is accurate. But more important than the facts themselves is the feeling they evoke, the sense of being part of something larger, something ancient and ongoing. You are not separate from nature. You are nature. The rivers that flow through wilderness also flow through you. The same physical laws that govern the falling of rain also govern the electrical impulses in your neurons. You are made of stardust and water, connected to everything that has ever lived, carrying within you the entire history of life on Earth. So settle yourself comfortably now. Adjust your pillow. Let your breathing slow and deepen. Feel the weight of your body supported, held securely. There's nowhere you need to be, nothing you need to do. For the next several hours, you can simply rest, simply listen, simply allow yourself to be carried along like a leaf on a river, turning gently in the current, moving without effort toward the vast, peaceful ocean of sleep. The river is waiting. The journey is beginning. But there is no rush. Rivers do not hurry. Water finds its way in its own time, patient and persistent, wearing away all obstacles through gentle, endless repetition. Like water, let yourself flow into this story, into this night, into the healing darkness of rest. Are you ready? There's no need to answer. The river doesn't ask if you're ready. It simply begins, as all rivers begin, with a single drop of rain, falling through cool mountain air, landing softly on ancient stone. Let us begin. Imagine, if you will, a single droplet of rain falling onto a mountainside. This droplet, so small and seemingly insignificant, begins a journey that mirrors one of the most profound mysteries of nature. For just as this water will flow and connect and nourish the land, so too does something remarkably similar happen within the landscape of your mind. Let us follow this droplet together and discover why the ancient peoples were right to see rivers as the veins of the earth, and why modern science has revealed that our brains contain rivers of their own. Our droplet lands softly on moss-covered stone, high in the mountains where the air is thin and pure. It begins to trickle downward, pulled by gravity, joining with other droplets. This is how all rivers begin, with precipitation, with rain and snow collecting in high places, gathering strength from countless tiny contributions. In the same way, the rivers of your brain begin at the very center, in deep chambers called ventricles, where a special fluid is born. This fluid in your brain is called cerebrospinal fluid, and your body creates about 500 milliliters of it every single day. Like a mountain spring that never runs dry, your brain produces this clear, protective liquid continuously, renewing it completely 3 to 4 times in a single day. It flows and circulates, just as our mountain stream begins to flow, finding its path through stone and soil. As our droplet travels downward, it joins a small brook. The water here is crystal clear, and it moves over smooth pebbles with a gentle, endless whisper. This brook is carving its path through the landscape, slowly but persistently shaping the very rock over which it flows. In your brain, the cerebrospinal fluid does something similar. It flows through narrow channels called aqueducts, the most famous being the cerebral aqueduct, a tiny passage that connects different chambers of the brain. This aqueduct is only about 3 millimeters wide, yet all the fluid that protects your brain must pass through this delicate gateway. The brook grows wider now, fed by other small streams joining from the sides. Scientists who study rivers call these tributaries, and they follow predictable patterns. There is even a principle called Horton's Law that describes how streams merge and grow. For every stream of a certain size, there tend to be about 3 to 5 smaller streams feeding into it. This branching pattern, this network of water finding its way, is echoed in the blood vessels of your brain, which branch and divide in similar fractal patterns, ensuring every cell receives the nourishment it needs. Our water flows onward, and the stream has become a young river now. It moves with purpose through a valley, its banks lined with willow trees whose roots drink deeply. A river like this might flow at a speed of 1 to 3 miles per hour in its calm sections, a walking pace, unhurried and steady. The cerebrospinal fluid in your brain flows at an even gentler pace, circulating from the ventricles around your brain and spinal cord at about 0.3 milliliters per minute. It is not the speed that matters, but the constancy, the reliable presence of this protective flow. Rivers have a remarkable ability to regulate temperature. The water holds heat from the sun, releasing it slowly, creating microclimates along its banks where life flourishes even in harsh seasons. Your brain uses its fluid in a similar way, maintaining a precise temperature of about 98.6 degrees Fahrenheit. The cerebrospinal fluid helps absorb and distribute heat evenly, protecting the delicate neural tissue from the damaging effects of temperature fluctuations. Just as fish and plants depend on the river's stable warmth, your neurons depend on this careful thermal regulation. As our river winds through the landscape, it begins to meander, creating those beautiful S-shaped curves that are so characteristic of rivers in flat country. These meanders form because water doesn't flow uniformly. The current moves faster on the outside of a bend, carving away the bank, while depositing sediment on the inside where the water slows. Over time, some meanders become so pronounced they loop back on themselves, and the river cuts through, leaving behind an oxbow lake, a crescent-shaped pool, peaceful and still. In your brain, the network of blood vessels also curves and bends, following the convoluted surface of the brain's cortex, dipping into valleys called sulci and rising over ridges called gyri. These vessels don't meander by chance, they follow the landscape they serve. The river is wide now, and deeper. In its depths, layers of water move at different speeds. The surface water, warmed by the sun and pushed by the wind, may flow quickly, while the water near the bottom, cooled and slowed by friction against the riverbed, barely moves at all. This layering is called stratification, and it affects everything in the river's ecosystem. Your brain has its own layers too. The cerebrospinal fluid exists in different spaces, including the subarachnoid space that surrounds the brain like a cushioning moat, and the deeper ventricles within. These spaces are connected, allowing the fluid to circulate completely, washing away waste products and delivering nutrients. Did you know that a river carries more than just water? Dissolved within every river are minerals, calcium, magnesium, sodium, and countless others leached from the rocks over which the water has flowed. A large river like the Amazon carries approximately 600 million tons of sediment to the ocean every year. Your cerebrospinal fluid also carries dissolved substances, proteins, glucose to feed your neurons, electrolytes like sodium and potassium that are essential for nerve signals to fire. It also carries away waste, the metabolic byproducts of your brain's constant work, transporting them to be filtered and removed. The river passes through a forest now, and the trees here are ancient, their roots reaching deep into the earth and also spreading near the surface, stabilizing the banks. These trees depend on the river, and the river depends on them. If the trees were removed, the banks would erode, and the river would become murky and unstable. This is a relationship of mutual support. In your brain, there is a similar partnership called the blood-brain barrier. The cells lining your brain's blood vessels fit together tightly, with almost no gaps, controlling what can pass from the blood into the brain tissue. The cerebrospinal fluid works alongside this barrier, maintaining the chemical balance your brain needs to function. As evening falls, the river reflects the orange and pink of sunset. The water holds light in a special way, bending it, reflecting it, creating shimmers and patterns. This happens because of the physics of refraction, the way light changes speed when moving from air into water. The human brain, too, responds to light, but in a different way. Light entering your eyes influences your circadian rhythm, your sleep-wake cycle, partly through effects on cerebrospinal fluid production and flow. The fluid circulation actually varies throughout the day, with increased flow during sleep, helping to clear away the waste products that accumulate while you're awake and thinking. Night descends, and the river continues its journey in darkness. Beneath the surface, life continues. Fish navigate by sensing pressure changes in the water, by feeling the river's current and flow. Rivers create sounds, too, the rushing and bubbling and gentle lapping that varies with speed and depth and obstacles. These sounds are soothing to human ears, perhaps because we evolved near water, because our ancestors knew that water meant life. The fluids of your brain create no sound you can hear, but if you could listen at the cellular level, you would hear a different kind of music, the electrical crackling of neurons firing, the chemical whispers of neurotransmitters crossing synapses, a symphony of thought itself. Our river has traveled far now, through mountains and valleys, through forests and plains. It has been joined by dozens of tributaries, and it has become a major waterway, hundreds of feet across. At this size, a river affects the weather. Water evaporates from its surface, rising into the air, forming clouds that may travel for miles before releasing their moisture as rain. The Amazon River, for example, releases so much water vapor that it influences rainfall patterns across an entire continent. Your brain also releases substances into your bloodstream that affect your entire body, hormones from the pituitary gland, neurotransmitters that regulate mood and energy. The brain, like a great river, shapes the environment around it. The river flows day and night without ceasing, and yet it changes with the seasons. In spring, swollen with snowmelt, it may rise 10 feet or more above its summer level, flooding the plains and depositing rich silt across the land. This seasonal flooding has sustained agriculture for thousands of years. The ancient Egyptians built their entire civilization around the predictable flooding of the Nile. Your cerebrospinal fluid also has rhythms, though measured in hours rather than months. Its flow increases during deep sleep, particularly during non-REM sleep, when your brain waves slow into long, rolling rhythms. During these periods, the fluid surges more vigorously through the brain, clearing away beta amyloid and other waste proteins that could, if allowed to accumulate, contribute to neurological diseases. Along the riverbank, we notice channels and wetlands where the water spreads out, creating shallow areas thick with reeds and rushes. These wetlands filter the water, removing pollutants and excess nutrients. They are the kidneys of the river system, cleaning and purifying. Your brain has a similar system called the glymphatic system, discovered only recently in 2012. This network of channels allows cerebrospinal fluid to wash through the brain tissue itself, mixing with the fluid between cells, collecting waste, and carrying it away. The glymphatic system is most active during sleep, which is one reason why sleep is so essential for brain health. The river is approaching the sea now, and it begins to slow, widening into an estuary where fresh water meets salt water. This is a place of incredible biodiversity, where species from both worlds come together. The mixing of waters creates unique conditions, gradients of salinity and temperature. In a similar way, the cerebrospinal fluid eventually drains into the venous blood through structures called arachnoid granulations, small protrusions where the fluid can pass through and rejoin the bloodstream. This is where the river of the brain returns to the ocean of the body's circulation. But let us step back and see the entire river system from above, as a bird might see it. From this height, the river and all its tributaries look like the branches of a tree, or like a network of veins, or like lightning spreading across the sky. This pattern, which mathematicians call a fractal pattern, appears throughout nature. It is the most efficient way to distribute something from many small sources to one large channel, or vice versa. Your brain's blood vessels follow this same pattern, branching and rebranching to supply every cubic millimeter of brain tissue. In fact, if you could lay out all the blood vessels in your brain end to end, they would stretch for about 400 miles. Rivers are powerful sculptors of the landscape. The Grand Canyon, one of Earth's most spectacular features, was carved by the Colorado River over millions of years. Water, flowing persistently, can cut through solid rock, moving particles grain by grain. The river doesn't force its way through, it simply persists, and the rock yields. In your brain, the cerebrospinal fluid also shapes its environment, though more subtly. The pressure of this fluid provides structural support, literally holding your brain in place within your skull. Your brain, which weighs about 3 pounds in air, weighs only about 1.5 ounces when suspended in cerebrospinal fluid. The fluid's buoyancy reduces the effective weight by more than 95%, preventing the brain from being compressed by its own mass. There are rivers beneath the earth as well, flowing through caves and underground channels, carving great caverns in limestone. These underground rivers are invisible from the surface, yet they can be enormous. In your brain, the blood vessels that supply deep structures are like these hidden rivers, traveling through white matter, bringing oxygen and glucose to parts of the brain that control basic functions like heartbeat and breathing, functions so automatic you never think about them. Rivers have their own chemistry, measured in pH and dissolved oxygen and nutrient levels. A healthy river typically has a pH between 6.5 and 8.5, neither too acidic nor too alkaline. Your cerebrospinal fluid also has a carefully regulated pH, normally around 7.33, slightly more alkaline than blood. This precise pH is essential because the electrical activity of neurons is sensitive to even small changes in acidity. Your brain works continuously to maintain this balance, using buffers and ion pumps, expending energy to keep conditions stable in an ever-changing body. The river provides transportation, and has done so for thousands of years. Boats and barges carry goods and people, moving with the current downstream, working against it upstream. The Native Americans of the Pacific Northwest traveled hundreds of miles along rivers in cedar canoes. In your brain, the cerebrospinal fluid and blood provide transportation too, carrying not boats but molecules, hormones, immune cells, nutrients, and waste products. These rivers of the body follow predictable routes, and when flow is disrupted by a blockage or hemorrhage, the effects can be devastating, like a river dammed or diverted. There is a rhythm to a river, a pulse. If you sit beside a river and watch carefully, you'll notice variations in the flow. Pulses of faster and slower water, eddies that form and dissolve, patterns that repeat. Some rivers have tides, influenced by the distant moon's gravity even hundreds of miles from the ocean. Your cerebrospinal fluid has rhythms too, influenced by your heartbeat and your breathing. With each heartbeat, the blood vessels in your brain expand slightly, and this pulsation helps drive the cerebrospinal fluid through its circuit. When you breathe deeply, the change in pressure within your chest and abdomen affects the pressure in your spinal canal, gently pumping the fluid up and down. Rivers have been sacred to humans throughout history. The Ganges in India, the Nile in Egypt, the Jordan in the Middle East, these rivers have been worshipped, been sites of pilgrimage, been thought to have healing properties. People have always intuited that water is life, that flow is health. modern medicine has confirmed this ancient wisdom in a new way. The flow of cerebrospinal fluid is indeed essential for health. When this flow is blocked, perhaps by a tumor or a malformation, the fluid accumulates, causing a condition called hydrocephalus, literally water on the brain. Pressure builds, causing symptoms and potentially brain damage. Restoring flow, usually by surgically placing a shunt to drain excess fluid, can be life-saving. The river nourishes the land through which it flows. Its annual floods leave behind layers of nutrient-rich sediment. The floodplains of great rivers are often the most fertile land in the world, capable of supporting dense populations. Ancient Mesopotamia, the cradle of civilization, developed between the Tigris and Euphrates rivers. Your brain's blood flow nourishes it in a similar way. Although the brain is only about 2% of your body weight, it receives approximately 15 to 20% of your body's blood supply. This rich blood flow delivers the enormous amount of glucose and oxygen your brain needs. Your brain uses about 20% of your body's total oxygen consumption and about 25% of its glucose. Thinking, it turns out, is energetically expensive. Rivers are habitats for incredible diversity. Freshwater rivers, though they cover only a tiny fraction of Earth's surface, are home to about 10% of all animal species. There are river dolphins, otters, countless fish species, amphibians, insects, and the many birds and mammals that depend on them. This diversity exists because rivers create so many different microhabitats: fast water and slow water, deep pools and shallow riffles, rocky bottoms and muddy banks. Your brain, too, is not uniform. Different regions have different structures, different concentrations of cells, different patterns of connectivity. There are areas specialized for vision, for hearing, for movement, for language, for emotion. The fluid that bathes all these regions is the same, yet each region uses it according to its own needs. As our river finally reaches the ocean, it fans out into a delta, splitting into many smaller channels that wind through wetlands and mudflats. These deltas are among the most productive ecosystems on Earth, nurseries for fish and nesting sites for birds. The river's journey doesn't truly end here. Its water joins the ocean, evaporates, forms clouds, and will eventually fall as rain on a mountain, beginning the cycle again. In your body, similarly, there is no true end. The cerebrospinal fluid drains into the blood circulates through the heart and lungs, delivers oxygen to cells, and the cells produce the energy that allows your brain to create more cerebrospinal fluid. Life is circulation, movement, flow. There is a Japanese concept, Mizu no Kokoro, which means mind like water. It refers to a mental state of calm and clarity, responsive but not disturbed, like a still pond that reflects everything perfectly but is instantly ready to ripple when touched. Rivers teach us this too, the ability to flow around obstacles rather than struggling against them, to carve a path through persistence rather than force, to nourish everything along our way. The river we have followed is every river and no particular river. It is the Amazon carrying more water than the next 7 largest rivers combined, discharging about 209,000 cubic meters of water into the Atlantic Ocean every single second. It is the Nile, At over 4,100 miles, the longest river in the world, flowing north through the desert, impossibly giving life where there should be none. It is the Mississippi, the Missouri, the Yangtze, the Thames, the Danube. It is the creek behind your childhood home, the stream you jumped across on a hike, the great waterway you've seen from a bridge. And the rivers of your brain, these too are universal and unique. Every human has the same basic anatomy, the same ventricles and aqueducts, the same protective cushion of fluid. Yet each brain is also absolutely individual, shaped by genetics and experience, by the thoughts you've thought and the life you've lived. The patterns of connections between your neurons are yours alone, as unique as your fingerprint. Scientists estimate that a typical river moves water from its source to the sea in anywhere from 2 weeks to 3 months, depending on the river's length and speed. The Mississippi River, for example, moves water from Minnesota to the Gulf of Mexico in about 90 days. Your cerebrospinal fluid completes its circuit much faster, turning over every 6 to 8 hours. In a single day, the same water molecules that cushion your brain in the morning have been replaced and refreshed several times over. Rivers can heal themselves. If a river is polluted but the source of pollution is removed, the water flushes through, carrying away contaminants, and life gradually returns. The recovery can be rapid. Some rivers have rebounded in just a few years. Your brain also has remarkable healing abilities. Neurons were once thought to never regenerate, but we now know that in certain areas, particularly the hippocampus involved in forming new memories, new neurons can be born throughout life. The cerebrospinal fluid carries growth factors that support this neurogenesis, these new births of brain cells. There is something deeply calming about water. Study after study has shown that time spent near rivers, lakes, or oceans reduces stress, lowers blood pressure, improves mood. The Japanese practice of forest bathing, Shinrin-yoku, is even more effective when the forest contains a stream or waterfall. Perhaps we find peace in water because we recognize, at some deep level, that we are water. Your body is about 60% water. Your brain is about 73% water. The cerebrospinal fluid that protects your brain, the blood that nourishes it, the cytoplasm inside each cell, all these are water with substances dissolved in it. We are, in a sense, seawater with a consciousness. The river's journey from mountain to sea mirrors the flow of time itself, always moving in one direction, never reversing, yet also eternal and cyclical. The water that flowed down this river 1,000 years ago has evaporated and rained and flowed again countless times. Some of those very same water molecules might be in your body right now, might be part of the cerebrospinal fluid flowing through your brain as you rest and listen. You are connected to ancient rivers and future oceans. You are part of the water cycle, part of the planet's great circulation. In your brain right now, as you drift towards sleep, the circulation of cerebrospinal fluid is increasing. The space between your brain cells is expanding slightly, allowing fluid to flow more easily through the tissue. This is your brain's cleaning cycle, its overnight maintenance. Waste proteins are being washed away. Memories are being consolidated, important connections strengthened, unnecessary ones pruned. Your brain is a river at night, flowing strong and clear. Rivers have carved the face of our planet. They have fed civilizations. They have inspired art and poetry and music. The river is everywhere, wrote Hermann Hesse. The river is everywhere at the same time, at the source and at the mouth, at the waterfall, at the ferry, at the current, in the ocean and in the mountains, everywhere, and that the present only exists for it, not the shadow of the past, nor the shadow of the future. In the same way, the rivers of your mind are everywhere in you. They flow through memory and motion, through sensation and speech, through dreams and waking. They connect the different parts of you into a unified whole. They carry your thoughts like leaves on water, sometimes turbulent, sometimes calm, but always moving, always alive. Let the river of sleep carry you now. Let your thoughts become like water, flowing easily, not catching on stones of worry or banks of planning. The river doesn't try to flow, it simply follows its nature. Your brain knows how to sleep, how to restore and refresh itself. Trust the ancient wisdom of water, of flow, of yielding to the natural path. The river continues its endless journey, from rain to creek to stream to river to ocean to cloud to rain again. Your breath rises and falls like tides. Your heartbeat pulses like water over stones. The cerebrospinal fluid circulates, protecting, nourishing, cleansing. You are a river. You are an ocean. You are the rain falling on a distant mountain, beginning the journey once more. And in the morning, when you wake, the river will still be flowing, as it always has, as it always will, constant and changing, forever new and ancient as time. Sleep now, and let the rivers carry you home. Let us return to the river once more, but this time, let us look deeper. Let us explore the currents beneath the surface, the hidden dynamics that make a river more than just water flowing downhill. If you were to drop a leaf onto a river's surface and watch it travel, you would notice something curious. The leaf doesn't move in a straight line. It spins, it circles, it moves sideways even as it flows downstream. This is because rivers flow in 3 dimensions, not just 2. The water spirals as it moves, creating helical flow patterns. Scientists discovered that in a typical river bend, the surface water moves toward the outside of the curve, while deeper water moves toward the inside. This spiraling motion, called secondary flow, helps keep the river channel clear of sediment and creates diverse habitats at different depths. In your brain, blood flow also follows complex 3-dimensional patterns. Blood doesn't simply flow in and flow out, it creates vortices and spirals, especially in areas where vessels branch or curve. These flow patterns affect how oxygen is delivered to tissues and how the vessel walls experience stress. Rivers breathe. This might sound strange, but it's true. The turbulent surface of a flowing river constantly exchanges gases with the atmosphere. Oxygen from the air dissolves into the water, while carbon dioxide produced by aquatic life bubbles out. A fast-flowing, tumbling river can absorb oxygen quickly, which is why rapids and waterfalls are such rich habitats for life. A slow, warm river in summer may become oxygen depleted, stressing the fish and other creatures living there. Your brain also breathes, though not through lungs. Every moment, oxygen diffuses from the blood vessels into the brain tissue, and carbon dioxide diffuses back. Your brain is so metabolically active that it cannot store energy. It depends on a constant supply of fresh, oxygenated blood. If blood flow to the brain stops for just 10 seconds, you lose consciousness. There are rivers that flow underground for part of their journey, disappearing into the earth only to resurface miles away. The Lost River in Indiana vanishes into a cave system and travels underground for 23 miles before emerging again. In some places, you can stand at a dry riverbed and hear the water rushing beneath your feet through limestone channels. Your brain has similar hidden pathways. The perivascular spaces, tiny channels that surround blood vessels, allow cerebrospinal fluid to penetrate deep into brain tissue. These spaces were long overlooked, considered merely empty gaps, but we now understand they're crucial highways for fluid exchange, part of the brain's waste clearance system. The power of a river is immense. The kinetic energy in flowing water has been harnessed by humans for thousands of years. Water wheels ground grain, sawed wood, powered early factories. Today, hydroelectric dams generate about 16% of the world's electricity. The Three Gorges Dam in China, the world's largest hydroelectric facility, has a generating capacity of 22,500 megawatts. This power comes from the simple fact of water falling, pulled by gravity, converted from potential energy to kinetic energy to electricity. Your brain generates its own electricity, though of a different kind. Every thought, every sensation, every movement begins with electrical signals passing between neurons. These signals are created by ions, charged particles, flowing across cell membranes, creating tiny voltage differences. A single neuron fires at about 0.07 volts, but with approximately 86 billion neurons, your brain generates enough collective electrical activity to be detected on your scalp by an EEG machine. Rivers have memory. This concept, called hysteresis, means that a river's current condition is influenced by its past conditions. If a river experiences a major flood, the changes to its channel, widening, deepening, the movement of large boulders, persist long after the flood recedes. The river carries the memory of that event in its altered form. Your brain's memory is far more complex, but it too is based on persistent changes. When you learn something, the connections between neurons strengthen. Proteins are synthesized, new synapses form, and these physical changes store the memory. Some memories, like the memory of how to ride a bicycle, can last a lifetime. The cerebrospinal fluid plays a role in memory formation. During sleep, when its flow increases, memories are consolidated, transferred from temporary storage in the hippocampus to more permanent storage in the cortex. Consider the watershed, the entire area of land that drains into a single river. The Mississippi River watershed covers about 1.2 million square miles, about 40% of the continental United States. Every raindrop that falls within this vast area will eventually make its way to the Mississippi and flow to the Gulf of Mexico. Watersheds have boundaries called divides, often marked by ridges or mountain ranges. Rain falling on one side of a divide flows to one ocean. Rain falling just a few feet away on the other side flows to a different ocean. Your brain has similar drainage divides. Different regions of the brain drain their metabolic waste through different routes. Some areas drain primarily through the glymphatic system, others through the walls of blood vessels, and others through the meningeal lymphatic vessels, only discovered in 2015, which carry fluid and immune cells away from the brain. Rivers sort and separate. As water flows, it carries particles of different sizes at different speeds. Heavy sand and gravel settle quickly in slow areas, while fine silt and clay can remain suspended for miles, only settling when the water becomes nearly still. This sorting creates distinct layers and sediment deposits, which geologists can read like pages in a book, reconstructing ancient flood events. Your cerebrospinal fluid also carries different substances at different rates. Small molecules like glucose diffuse quickly, larger proteins move more slowly. Some substances are actively transported by special carrier molecules, while others must wait for bulk flow to carry them along. This selective transport is one way your brain controls its internal environment. The color of a river tells a story. Clear blue water indicates low nutrients and sediments, often from deep, cold sources. Green water suggests abundant algae, fed by nutrients. Brown or tan water is heavy with sediment. The Amazon has black water tributaries, stained dark by tannins from decomposing leaves, and white water tributaries, cloudy with Andean sediment. Where they meet, the different colored waters can flow side by side for miles before finally mixing. Your cerebrospinal fluid is normally crystal clear, like pure spring water. If it becomes cloudy or discolored, it indicates a problem, infection, bleeding, or inflammation. Doctors can analyze cerebrospinal fluid by performing a lumbar puncture, inserting a needle between vertebrae to withdraw a small sample. The fluid's clarity, color, pressure, and chemical composition provide diagnostic clues about brain health. Rivers create their own weather. Large rivers add moisture to the air through evaporation, increasing local humidity and often creating morning mists that hang above the water. In tropical regions, rivers contribute to the formation of convective storms. The Amazon releases approximately 20 billion tons of water into the atmosphere each day through evaporation and transpiration from riverside forests. Your brain affects your body's entire system in analogous ways. The hypothalamus, a small region at the brain's base, controls body temperature, thirst, hunger, and sleep cycles. It senses the temperature of blood flowing through it and sends signals to adjust sweating, shivering, and blood vessel dilation. The hypothalamus also controls the pituitary gland, which releases hormones that regulate growth, reproduction, and stress response throughout the body. Frozen rivers tell their own story. When temperatures drop, ice forms on a river's surface, but the process is complex. Ice doesn't form uniformly. It often starts at the edges where water is shallow and calm. The flowing water in the center may remain liquid even in extreme cold because moving water is harder to freeze. In the far north, rivers like the Yukon freeze solid enough to drive trucks across, becoming winter highways. The ice can be several feet thick, yet beneath it, water still flows, and fish still swim in the dark. Your brain cannot freeze, of course, but it is sensitive to temperature. Even a fever of a few degrees can affect brain function, causing confusion or delirium. Hypothermia, on the other hand, slows brain activity dramatically. Surgeons sometimes deliberately cool the brain during complex operations, reducing its metabolic needs and providing protection during periods of reduced blood flow. Every river has a characteristic sound, a voice. A mountain stream chatters and splashes over rocks. A large, Slow river murmurs deeply, a bass note beneath the wind. Rapids roar and hiss with white water. People who live beside rivers learn to hear changes in the sound. A rising river sounds different, fuller, and more urgent. Sound in water travels about 4 times faster than in air, at approximately 3,300 miles per hour. Marine mammals use this property for echolocation and communication. Your brain processes sound with remarkable sophistication. The auditory cortex can distinguish between frequencies that differ by less than 1%. It can locate a sound source to within a few degrees based on tiny differences in timing and volume between your 2 ears. The cerebrospinal fluid that surrounds your brain doesn't carry sound the way air does, but it does conduct vibrations. This is one reason why a skull fracture or abnormal fluid pressure can cause hearing problems. Rivers migrate. This is not a metaphor. Rivers literally move across the landscape over time. As a meandering river erodes the outside of bends and deposits sediment on the inside, the entire channel shifts sideways. The Mississippi River has migrated across a floodplain dozens of miles wide, abandoning old channels and carving new ones. Some ancient civilizations, their ruins now miles from the river, were once riverside cities. In your lifetime, your brain also changes its landscape. This ability is called neuroplasticity. The brain you have today is not the brain you had 10 years ago. Connections that are frequently used strengthen and grow. Those rarely used weaken and may be pruned away. People who lose their sight often develop enhanced hearing, as the brain region that once processed vision is recruited for auditory processing. London taxi drivers, who must memorize the complex city streets, develop enlarged hippocampi, the brain region involved in spatial navigation. At the mouth of many rivers, where fresh water meets the sea, there is a constant struggle, a boundary that shifts with the tides and the river's flow. During flood stage, the river pushes far out into the ocean, its fresh water floating atop the denser salt water. During dry seasons, salt water pushes upstream, sometimes for many miles. This mixing zone, the estuary, is one of Earth's most productive habitats precisely because of this dynamic boundary, this constant exchange. Your brain also has boundaries, though they're measured in molecules rather than miles. The blood-brain barrier is selective, allowing water, oxygen, and certain nutrients through while blocking most large molecules, proteins, and bacteria. This protection is essential, but the barrier isn't absolute. It has weak points, areas called circumventricular organs where it's more permeable, allowing the brain to sense hormones and other signals in the blood. Rivers respond to the moon, though we rarely think of them in this way. While ocean tides are obvious, large rivers connected to the sea also experience tidal effects. The Amazon's tidal bore, called the pororoca, is a wave that travels upstream with the incoming tide, sometimes reaching 12 feet high and traveling at 15 miles per hour. Surfers ride it for miles. Even rivers far from the ocean can be affected by the moon's gravity, though the effect is measured in millimeters rather than feet. Your body also responds to rhythms. The circadian rhythm, Your 24-hour cycle of sleep and wakefulness is controlled by a tiny region of your hypothalamus called the suprachiasmatic nucleus. This cluster of about 20,000 neurons acts as your internal clock, using light signals from your eyes to synchronize your body to the day-night cycle. The flow of cerebrospinal fluid follows this rhythm, increasing at night to clear away the day's accumulated waste. There exist rivers beneath the ocean, distinct channels of denser, salter water flowing along the seafloor, sometimes for hundreds of miles. The Black Sea has an undersea river flowing through it, complete with waterfalls and rapids, discovered only through sonar mapping. These underwater rivers are invisible from the surface yet massive in scale. Your brain also has structures visible only through special techniques. Functional MRI scanning can reveal patterns of blood flow, showing which regions are active during different tasks. Diffusion tensor imaging traces the white matter tracks, the bundles of axons that connect different brain regions, revealing a network of information highways invisible to the naked eye. The chemistry of rivers is a delicate balance. The pH, the dissolved oxygen, the concentrations of nitrogen and phosphorus, all must fall within certain ranges for the ecosystem to thrive. Too much nitrogen, often from agricultural runoff, causes algae blooms that deplete oxygen and create dead zones. Rivers are sensitive indicators of watershed health. Your cerebrospinal fluid's chemistry is equally delicate and equally revealing. Its glucose level normally parallels blood glucose but is slightly lower, about 60% of blood levels. Protein concentration is low, normally less than 45 milligrams per deciliter. White blood cell count should be nearly zero. Deviations from these values indicate specific problems. High protein might suggest inflammation or a tumor. High white cell count indicates infection. Blood cells indicate hemorrhage. Consider the lifespan of water in a river. Some rivers are fed primarily by rainfall, responding quickly to storms. Their water is young, perhaps only days or weeks old. Other rivers are fed by deep groundwater that fell as rain decades or even centuries ago. The Great Artesian Basin in Australia contains water that fell as rain over 20,000 years ago, slowly filtered through rock layers, and now emerges in springs feeding rivers. The age of water affects its chemistry and its story. The fluid in your brain turns over every 6 to 8 hours, as we discussed, but the water molecules themselves have their own ancient journeys. The water in your body today has been part of clouds and oceans, has been drunk by dinosaurs and ancient humans, has traveled through countless living things. You are a temporary vessel for water that is, in a sense, timeless. Rivers carve valleys not just through erosion but through a process called hydraulic action. Water flowing into cracks exerts pressure, forcing the cracks wider. In winter, water freezes in these cracks, expanding and fracturing the rock further. Over thousands of years, these processes can cleave mountains. But rivers also build. They create levees, natural raised banks formed from sediment deposited during floods. They create deltas, adding new land to coastlines. The Nile Delta has been growing for thousands of years, built from soil carried from the highlands of Ethiopia. Your brain also has dual processes of breaking down and building up. Protein degradation and synthesis occur constantly. Synapses are created and eliminated. The balance between these processes is crucial. Disruptions contribute to neurodegenerative diseases like Alzheimer's, where waste proteins accumulate, and to autism spectrum disorders, where synaptic pruning may be disrupted. In winter, when a river's surface freezes, something remarkable happens. Ice is less dense than water, which is why it floats. This unusual property means that freezing begins at the top rather than the bottom, insulating the liquid water beneath and allowing aquatic life to survive even when air temperatures plunge far below freezing. If ice sank, rivers and lakes would freeze solid, and life in cold climates would be nearly impossible. Water is one of the few substances with this property. Your brain depends on water's unique properties too. Water is an excellent solvent, allowing nutrients, gases, and waste products to dissolve and be transported. It has a high specific heat capacity, meaning it can absorb or release significant amounts of heat with only small temperature changes, helping stabilize your brain's temperature. And water is essential for the structure of proteins and cell membranes. Without water, the molecules of life would collapse into useless tangles. The gradient of a river, how steeply it descends, determines its character. Mountain streams with steep gradients flow fast and straight, cutting V-shaped valleys. Rivers and flat plains have gentle gradients, flowing slowly, meandering widely, creating broad floodplains. The gradient determines what lives in the river too. Fast water is too energetic for some species but perfect for others that have evolved to cling to rocks or swim against powerful currents. Within your brain, there are also gradients, concentration gradients of ions across cell membranes, electrical gradients that drive nerve signals, pressure gradients that drive fluid flow. These gradients represent potential energy, and cells expend considerable effort to maintain them, using molecular pumps powered by ATP, the energy currency of cells. Rivers are resilient, yet they can be broken. Dam a river, and the entire ecosystem downstream changes. Sediment that once nourished the delta piles up behind the dam. Fish that once migrated upstream to spawn are blocked. The river's temperature changes, its flow becomes regulated rather than natural, and species adapted to seasonal floods and droughts struggle to survive. Yet remove the dam, and recovery can be surprisingly swift. When the Elwha Dam in Washington state was removed in 2011, salmon returned to stretches of river they hadn't reached in a century. Your brain also has remarkable resilience, called cognitive reserve. People with more education, more complex jobs, or more social engagement seem to tolerate more age-related brain changes before showing symptoms of dementia. It's as if they've built a more robust network with multiple backup pathways. But the brain has its breaking points too. Severe trauma, stroke, or degenerative disease can cause damage that's difficult or impossible to reverse, especially in adults, whose brains have less regenerative capacity than children's brains. If you trace any river upstream far enough, you find not a single source but many, dozens or hundreds of springs and seeps, water emerging from the ground. These sources are fed by the watershed, by rain that has percolated through soil and rock. The river is the visible expression of invisible processes, the culmination of countless small contributions. Your brain, too, is the expression of countless processes, genetic instructions being read, proteins being synthesized, ions flowing across membranes, neurotransmitters binding to receptors, electrical signals cascading through networks. Consciousness, your awareness, your sense of self, emerges from all these tiny events, none of which is itself conscious, yet together they create the inner world of your experience. Some rivers reverse their flow. The Chicago River was famously engineered to reverse, now flowing away from Lake Michigan instead of into it. The Tunnel Sap River in Cambodia naturally reverses twice a year, flowing into the Mekong during dry season and away from it during the monsoon. Your brain can also reverse or redirect its processes through attention. You can decide to focus on one sound while ignoring others, to recall a specific memory, to move your hand in a particular way. This voluntary control, called executive function, depends on your prefrontal cortex, the region just behind your forehead. Damage to this area impairs planning, decision-making, and impulse control, while leaving basic functions like breathing and heartbeat unaffected. The journey of a river is patient. It may take weeks for water to travel from source to sea, and decades or centuries for the river to significantly alter its course. The Grand Canyon took 5 to 6 million years to form, a timescale almost beyond human comprehension. Yet the river never stops, never rests. Its power is in its persistence. Similarly, the changes in your brain occur slowly. Learning a new language, mastering a musical instrument, or developing expertise in any field requires months or years of practice. Each practice session strengthens relevant connections minutely. No single session creates expertise, but the accumulated effect of consistent effort reshapes your brain, creating new competencies that become automatic, effortless. Let the river carry you deeper into rest now. Feel its endless patience, its tireless flow. Like water wearing away stone, like the seasons turning, like the tide's eternal rhythm, the processes of life continue whether we attend to them or not. Your heart beats without your instruction. Your lungs breathe while you sleep. The rivers of your mind flow on, clearing, nourishing, protecting. You are resting in the embrace of ancient patterns, older than humanity, older than thought itself. Water has flowed across this planet for billions of years, carving and nourishing and returning always to the sea. Your mind is a brief eddy in this eternal current, a temporary pattern that will dissolve and flow onward, your molecules joining the great cycle once more. But for now, in this moment, you are a river flowing through a living landscape. You are the rain in the sea, the mountain spring in the delta marsh. You are the current in the stillness, the surface in the depths. Rest in the flow. Trust the current. Let the river carry you to the ocean of sleep, where all rivers go, where all thoughts dissolve into the dark, peaceful water of dreamless rest. The river flows on, and so do you, effortlessly, endlessly, home. We have traveled far along our river, yet there are still mysteries to explore, depths to sound, secrets held in the moving water. Let us go deeper still, into the subtle and the profound. Consider the source of a river's power, gravity. Water flows downhill because Earth pulls it. This seems simple, obvious even, yet gravity is one of the universe's fundamental forces, bending space and time itself. A river is matter responding to the curvature of space-time, following what physicists call a geodesic, the straightest possible path through bent space. In a way, the river isn't flowing at all, it's standing still while the Earth falls away beneath it. Your brain also works within gravity's influence. Blood flow to the brain changes when you stand up or lie down. Stand suddenly, and gravity pulls blood away from your head. You might feel briefly dizzy until your cardiovascular system compensates, constricting blood vessels and increasing heart rate. The cerebrospinal fluid, too, experiences gravity. Its pressure is greater at the base of your spine than at the top of your head when you're standing, a gradient of about 40 centimeters of water pressure. Rivers create microclimates that extend far beyond their banks. The moisture they provide can support forests and otherwise dry regions. The Colorado River once created a green corridor through the desert, supporting cottonwood and willow forests that stretched for hundreds of miles. Animals migrated along these river corridors, using them as highways through inhospitable terrain. Your brain's blood vessels create similar corridors, routes of high metabolic activity. Where blood flow is rich, neural activity is vigorous. Brain imaging exploits this relationship. Functional MRI measures blood oxygenation to infer which brain regions are active. When you read these words, blood flow increases slightly to your visual cortex and language areas. The pattern of blood flow reveals the pattern of thought, a map of mental activity drawn in flowing blood. Every river carries a chemical signature, a unique mixture of dissolved minerals that reflects the geology of its watershed. The Amazon, draining ancient, weathered rocks, carries different minerals than the Colorado, which cuts through younger formations rich in calcium carbonate. Scientists can identify where a fish was born by analyzing trace elements in its bones, reading the chemical fingerprint of its home river. Your brain tissue also has a chemical signature. Different neurotransmitters are concentrated in different regions. Dopamine in the substantia nigra and striatum, involved in movement and reward. Serotonin in the raphe nuclei, involved in mood. Acetylcholine in the basal forebrain, involved in attention and memory. These chemical landscapes shape function, and disruptions in neurotransmitter balance contribute to disorders like Parkinson's disease, depression, and Alzheimer's. Rivers transport nutrients across vast distances, connecting ecosystems that seem separate. Salmon, born in freshwater streams, migrate to the ocean to grow, then return to their birth streams to spawn and die. Their decomposing bodies deliver marine nutrients, nitrogen, phosphorus, carbon, to the stream ecosystem, fertilizing the very waters where their offspring will hatch. Studies in Alaska found that trees growing near salmon streams incorporate measurable amounts of nitrogen derived from the ocean, carried thousands of miles by these fish. Your brain also imports nutrients from distant sources. The glucose that powers your neurons comes from food digested in your intestines, absorbed into blood, and carried to your brain. Your brain cannot store significant energy reserves. It depends on continuous delivery. This is why blood glucose levels affect mental function. Too low, and you feel confused, irritable, unable to concentrate. The brain, for all its complexity, runs on simple sugar, delivered by the body's circulatory rivers. There exist rivers of air, though we don't often think of them this way. The jet streams that circle the globe are enormous, high-altitude currents of wind, flowing at speeds up to 275 miles per hour. These atmospheric rivers shape weather across entire continents. Closer to the surface, prevailing winds create predictable patterns that sailors and pilots have exploited for centuries. Your body has currents of air too, breathing. Each breath brings about 500 milliliters of air into your lungs, where oxygen diffuses into blood and carbon dioxide diffuses out. Your brain is exquisitely sensitive to blood oxygen and carbon dioxide levels. Special receptors in your carotid arteries and brainstem constantly monitor these gases. Too much carbon dioxide, and your brainstem commands you to breathe faster, deeper. The rhythm of breathing, controlled by the respiratory centers in your medulla and pons, is so fundamental that it continues even when you're unconscious, even in the deepest sleep. The sound of flowing water is mathematically interesting. It's not random noise, but something called pink noise or 1/f noise, where lower frequencies have more power than higher frequencies. This type of sound is common in nature, rustling leaves, rainfall, ocean waves, and humans find it soothing, perhaps because we evolved in environments rich with such sounds. Pink noise can improve sleep quality and mask disruptive sounds more effectively than white noise. Your brain produces its own rhythmic electrical activity, detected by EEG as brain waves. Delta waves, the slowest at 0.5 to 4 cycles per second, dominate during deep sleep. Theta waves, at 4 to 8 cycles per second, occur during drowsiness and light sleep. Alpha waves, 8 to 13 cycles per second, appear when you're awake but relaxed with eyes closed. Beta waves, 13 to 30 cycles per second, accompany active thinking. And gamma waves, above 30 cycles per second, may be involved in consciousness itself, binding together different sensory inputs into unified perception. Rivers can disappear, not just underground, but entirely. The Okavango River in Botswana never reaches the ocean. It spreads out into the Kalahari Desert, creating a vast inland delta where the water simply evaporates. The Humboldt River in Nevada flows through desert until it ends in a sink, a depression where the water collects and disappears, leaving behind salt flats. These endorheic basins with no outlet to the sea, cover about 18% of Earth's land surface. Water enters but leaves only by evaporation. In your brain, the cerebrospinal fluid does eventually drain away, but not by evaporation. It returns to the bloodstream through arachnoid granulations and along nerve roots exiting the skull. Recently, scientists discovered that some cerebrospinal fluid drains through the cribriform plate, a perforated bone at the skull's base, into the lymphatic vessels in the nose. This pathway may be significant for clearing large molecules and proteins from the brain. temperature zones in a river create invisible boundaries. Fish are cold-blooded. Their body temperature matches the water around them. A cold water fish like a trout will die if water temperature exceeds about 75 degrees Fahrenheit. Warm water fish like bass thrive in temperatures that would stress trout. Rivers with cold headwaters and warm lower reaches host different communities at different points. Your brain also has temperature zones, though the variations are smaller, measured in fractions of a degree. The hypothalamus, which regulates body temperature, is kept slightly cooler than other brain regions. During intense mental effort, local brain temperature can increase slightly due to metabolic heat production. Fever affects the brain globally, and severe hyperthermia, core temperature above 104 degrees Fahrenheit, can cause delirium, seizures, and brain damage. Rivers are fractal, meaning they show similar patterns at different scales. A tiny rivulet follows the same branching logic as a massive river system. The angle at which tributaries join the main channel, typically about 72 degrees, is consistent from the smallest streams to the largest rivers. This self-similarity is a fundamental property of river networks, a consequence of water seeking the most efficient path to lower elevation. Your lungs are fractal too, branching repeatedly from the trachea down through bronchi and bronchioles to millions of tiny air sacs called alveoli. This branching maximizes surface area for gas exchange within the limited volume of your chest. Your brain's blood vessel network is also fractal, efficiently distributing blood to approximately 100 billion cubic millimeters of brain tissue. Evolution tends to discover fractal solutions because they're mathematically optimal for distribution networks. The Amazon River discharges so much fresh water, about 55 million gallons per second, that it dilutes the ocean's salinity up to 100 miles offshore. Sailors could drink fresh water from the ocean surface while still out of sight of land, a phenomenon that mystified early explorers. This massive discharge affects ocean currents, marine life, and even weather patterns across the Atlantic. Your brain, though tiny compared to the Amazon, also has outsized effects. Despite being only 2% of your body weight, your brain's activity influences your entire physiology. The autonomic nervous system, controlled by your brainstem and hypothalamus, regulates heart rate, blood pressure, digestion, and immune function. Stress perceived by your brain triggers the release of cortisol and adrenaline, affecting organs throughout your body. Your brain doesn't just experience your life, it orchestrates your body's response to that experience. Some rivers run red, not with blood, but with iron-rich sediment or tannins. The Red River in the southern United States carries red clay. The Rio Tinto in Spain is literally acidic, with a pH of 2, due to mining activities and natural mineral content. Its water is rusty orange, rich with dissolved iron. Extremophile bacteria thrive in these harsh waters, species found nowhere else, adapted to conditions that would kill most life. Your blood appears red because of hemoglobin, the iron-containing protein that carries oxygen. Hemoglobin in your red blood cells binds oxygen in your lungs and releases it in your tissues. Without adequate iron, you develop anemia, your blood carries less oxygen, and you feel tired, weak, unable to think clearly. Your brain, despite its small size, demands about 20% of your body's oxygen supply. Anything that reduces oxygen delivery, anemia, lung disease, carbon monoxide poisoning, affects brain function first and most severely. Rivers create natural borders, and humans have long recognized these boundaries. More international borders follow rivers than any other natural feature. The Rio Grande marks much of the border between the United States and Mexico. The Danube flows through 10 countries, the most of any river. These watery boundaries are practical, easy to see, difficult to cross, but they also shift as rivers change course. Border disputes have arisen when rivers move, leaving territory on the wrong side. Your brain also has borders, though made of tissue rather than water. The cerebral cortex is divided into two hemispheres, left and right, connected by a bundle of about 200 million nerve fibers called the corpus callosum. These hemispheres have some functional specialization. For most people, language is predominantly in the left hemisphere, while spatial processing is stronger in the right. But this is a matter of degree, not absolute division. The hemispheres communicate constantly, integrating their processing into unified experience. Waterfalls are rivers in free fall, gravity's pull unobstructed. The tallest waterfall in the world, Angel Falls in Venezuela, drops 3,212 feet. Water falls for so long it often becomes mist before reaching the bottom. At the base of powerful waterfalls, the constant pounding carves deep pools, called plunge pools, and the mist creates microclimates where rare plants grow. Waterfalls also generate negative ions, oxygen molecules with an extra electron, which some studies suggest may improve mood and alertness, though the evidence is not conclusive. Your brain experiences no waterfalls, but it does have fluid flowing through pressure gradients, descending from areas of higher pressure to lower. If this pressure becomes unbalanced, for instance, if cerebrospinal fluid cannot drain properly, intracranial pressure rises, a dangerous condition that can compress the brain, causing headaches, vision problems, and potentially herniation, where brain tissue is pushed through openings in the skull. Ice ages have dramatically altered rivers. During the last glacial maximum, about 20,000 years ago, so much water was locked in ice sheets that sea levels were 400 feet lower than today. Rivers flowed across what is now continental shelf. The Thames and Rhine merged into a single river flowing across exposed land now beneath the North Sea. When the ice melted, sea levels rose, drowning these river valleys, creating the coastlines we know. Your brain also has a deep past, shaped by evolution over millions of years. The brainstem, which controls vital functions, is evolutionarily ancient, similar in structure to the brains of reptiles. The limbic system, involved in emotion and memory, is mammalian, shared with other mammals. The cerebral cortex, especially the prefrontal cortex, is most developed in primates and especially in humans. This evolutionary layering means your brain is not a single design system but a collection of systems, built upon and around each other, sometimes working in harmony, sometimes in conflict. Consider river deltas from space. The Nile Delta, the Mississippi Delta, the Ganges-Brahmaputra Delta, from orbit, they look like trees, or like neurons, or like blood vessels, branching and rebranching in fractal complexity. This pattern appears because the same mathematical principles govern all distribution networks, whether carved by water, grown by biological processes, or designed by evolution. The Ganges-Brahmaputra Delta, the largest delta in the world, covers about 41,000 square miles and is home to 130 million people. It's a landscape in constant flux, as the rivers deposit sediment and shift their channels, building land in some areas while eroding it in others. Your brain's structure also changes throughout your life, though on a microscopic scale. Synapses form and dissolve, dendritic spines appear and disappear, neurons adjust their sensitivity to inputs. This ongoing plasticity is greatest in childhood but continues throughout life, allowing you to learn and adapt until the very end. Rivers have been highways for human migration and trade since prehistory. The first civilizations arose beside rivers: the Nile, the Tigris and Euphrates, the Indus, the Yellow River. Rivers provided water, food, fertile soil, and transportation. Even today, rivers carry enormous volumes of cargo. The Rhine is one of the busiest waterways in the world, with more than 300 million tons of freight annually. Your brain's highways are the axon tracks, bundles of nerve fibers connecting different regions. The corpus callosum, connecting the hemispheres, is the brain's largest axon bundle. Other major tracts include the corticospinal tract, carrying movement commands from brain to spinal cord, and the optic nerves, carrying visual information from eyes to brain. These tracts are composed of axons, some wrapped in myelin, a fatty insulation that speeds electrical conduction. Myelin makes signals travel up to 100 times faster than an unmyelinated fibers, allowing rapid communication across the brain's 3 pounds of tissue. There are rivers that flow uphill, in a sense. Tidal bores, like the Amazon's Pororoca, are waves that travel upstream against the current. The Severn Bore in England can reach 9 feet high and travel inland for 25 miles. These bores are caused by tidal forces overpowering the river's downstream flow. In your body, blood sometimes flows uphill too, against gravity. When you stand, blood must be pumped from your legs back to your heart, fighting gravity every inch. Your veins have one-way valves that prevent backflow, and muscle contractions squeeze veins, pushing blood upward. If these mechanisms fail, blood pools in the legs, causing varicose veins and, in severe cases, insufficient blood return to the heart, reducing blood pressure and brain perfusion. This is why standing motionless for too long can cause fainting. Moving your legs helps pump blood back to your heart and brain. River ice has structure. It doesn't freeze uniformly but forms crystals, each with hexagonal symmetry, reflecting water's molecular geometry. These crystals interlock, forming sheets and flows. Pancake ice, formed in turbulent water, creates circular plates with raised edges. Fragile ice forms as tiny needles and platelets in supercold water. The Arctic rivers that freeze solid in winter become, in spring, scenes of dramatic breakup, as ice cracks and flows downstream in vast rafts, sometimes jamming and creating temporary dams, followed by sudden, catastrophic releases. Your brain's structure also has crystalline order at the molecular scale. Proteins fold into precise three-dimensional shapes, with atomic precision. Cell membranes are organized lipid bilayers with consistent thickness and orientation. This molecular order enables function. Proteins are not random tangles but precisely shaped tools, each performing specific chemical reactions. The longest river in the world, whether it's the Nile or the Amazon, is debated, depending on how you measure, stretches over 4,000 miles. To follow a single water molecule along this journey would take months. Yet rivers are also local, intimate. Every place along a river is its own ecosystem, its own character. You can know a river by knowing one bend, one pool, one riffle. Your nervous system extends similarly. From brain to the tips of your toes, your nerves span your entire body. The sciatic nerve, the longest in your body, runs from your lower back down through your leg, nearly 4 feet in some people. Yet each segment of this nerve serves its local area, and you can experience sensation or movement problems in just one small region if that part of the nerve is damaged. Groundwater is the hidden sibling of rivers, the water stored in aquifers, porous rock formations underground. The Ogallala Aquifer beneath the Great Plains holds as much water as Lake Huron, accumulated over thousands of years. This groundwater slowly seeps into rivers, maintaining their flow even during droughts. Without groundwater contribution, many rivers would be intermittent, flowing only after rain. Your brain has no stored reserves of glucose or oxygen, but it does have reservoirs of other kinds. Your memories are stored, encoded in the pattern of synaptic strengths throughout your cortex. Your skills are stored as refined motor programs in your cerebellum and basal ganglia. Your personality is stored, in a sense, as the characteristic patterns of activity and connectivity that make your brain uniquely yours. These are not physical reservoirs but informational ones, patterns rather than substances, yet they persist over decades, shaping who you are. When a river floods, it can be devastating, but floods are also renewing. The silt deposited by floods is mineral-rich, replenishing soil nutrients. Before the Aswan Dam, the Nile's annual floods left a layer of fresh silt that made Egypt the breadbasket of the ancient world. Farmers could predict their yield by how high the Nile rose. Your brain also benefits from occasional challenges, from experiences that push you beyond your comfort zone. Learning is often uncomfortable. It requires effort, attention, the willingness to fail and try again. But each learning experience strengthens neural connections, builds new synapses, enhances cognitive reserve. A life of constant routine, without novelty or challenge, may be comfortable but provides less stimulus for maintaining brain health. Just as a river needs its floods, your brain needs its challenges. Rivers respond to seasons in complex ways. Snow melt in spring creates a predictable surge. Summer thunderstorms cause flash floods. Autumn's lower flows concentrate fish in deeper pools. Winter may bring ice or, in milder climates, the rainy season. Species along the river have evolved to time their life cycles to these rhythms. Salmon spawn during specific flows. Cottonwood seeds germinate on fresh sandbars exposed by receding floods. Your body's rhythms are equally complex. The circadian rhythm is best known, But there are also ultradian rhythms, cycles shorter than 24 hours, like the 90-minute REM cycle during sleep, and infradian rhythms, longer than 24 hours, like women's menstrual cycles. These rhythms are generated by oscillating patterns of gene expression and protein synthesis within cells, clocks within clocks, all synchronized by signals from the suprachiasmatic nucleus, your brain's master clock. Let us imagine now that we are water molecules, part of the river's flow. We cannot see the river as a whole. We know only the molecules around us, the push of current, the tumbling over rocks, the slow drift through deep pools. Yet we are part of something larger, a flow that has purpose and direction, even though no single molecule knows where the river is going. Your neurons are like this. Each neuron responds to its inputs, fires or doesn't fire, influences its neighbors. No single neuron knows what it's computing. Yet the collective activity of billions of neurons creates thought, memory, consciousness itself. You are not located in any single neuron, any single synapse. You are the pattern, the flow, the river itself. The river is dark now, flowing through the deep night. Overhead, stars reflect on its surface, points of light moving and wavering with the current. The river's sound changes in darkness, seems louder, more present when you cannot see it. Nocturnal animals come to the water's edge, deer, raccoons, owls hunting along the banks. The river is as alive at night as during the day, just differently. Your brain, too, is intensely active during sleep. It is not resting but engaged in different tasks, consolidating memories, clearing waste, rehearsing and pruning synapses. The sleeping brain consumes almost as much energy as the waking brain. Sleep is not an absence but another kind of presence, another mode of being. The river flows past a sleeping village, past darkened homes, past dreaming people. In their dreams, some might see rivers, might fly over water or swim in clear streams. Dreams have fascinated humans forever, yet we still don't fully understand them. We know they occur mainly during REM sleep, when the brain is highly active but the body is paralyzed to prevent acting out dreams. We know the limbic system, especially the amygdala, is more active during dreams, while the prefrontal cortex is less active, which might explain dreams' emotional intensity and logical bizarreness. But why we dream, what dreams mean, whether they have meaning, these questions remain mysteries, as deep and flowing as the river itself. Rest now in the river's embrace. Let go of questions, of seeking, of trying to understand. The river doesn't try to flow, it simply flows. Your breath doesn't try to breathe, it simply breathes. Your heart doesn't try to beat, it simply beats. The rivers of your mind flow on, whether you watch them or not, doing their ancient work, following patterns older than consciousness. You are safe here, floating in the current of existence, carried gently through the night. The river knows the way. The river has always known the way. From mountain to sea, from rain to cloud to rain again, the water returns, cycles, continues. Be the river. Be the flow. Be the current that asks no questions and seeks no destination, content simply to move, to change, to carry life along in its endless, peaceful journey home. And so our river has carried us through the long night, through darkness and starlight, through the deep hours when the world is most still. We have traveled from mountain peak to ocean shore, following water's ancient path, and in following the river, we have traced the currents that flow within you. Perhaps you are still awake, still listening. Perhaps you drifted away long ago and are only now returning, rising toward the surface like a fish sensing the dawn. Or perhaps you never left at all, but floated in that liminal space between waking and sleeping, that gentle borderland where consciousness blurs and softens and becomes like water itself. Wherever you have been, you are here now. And here is perfect. Here is exactly where you need to be. Let us take a moment to honor what we have discovered together. We have learned that rivers and brains are not merely similar by metaphor, but are fundamentally connected by the same principles: flow, circulation, nourishment, cleansing. We have seen how water shapes stone over centuries, and how thought shapes the brain over years. We have understood that both rivers and minds are never static, never finished, but always moving, always changing, always becoming. You began this journey as one person, but in a sense, you are not quite the same person now. Every moment you've listened, your brain has been active. Synapses have fired. Memories have been encoded. The very act of hearing these words, of imagining rivers and mountains and flowing water, has subtly altered the physical structure of your brain. New connections have formed, weak ones have strengthened, and your neural landscape has shifted, however slightly. This is the miracle of neuroplasticity, the river-like quality of your mind. You are not fixed. You are not finished. Even now, even in rest, even in sleep, you are changing, growing, adapting. Your brain is washing away the day's metabolic waste, consolidating important memories, pruning unnecessary connections. The rivers of your mind are doing their patient work, as they do every night, as they will do every night for as long as you live. And when morning comes, not yet, but eventually, when the time is right, those rivers will still be flowing. You will wake, and the cerebrospinal fluid will still be circulating. Your blood will still be pulsing through hundreds of miles of vessels. The glymphatic system will transition from its nighttime cleaning mode back to daytime functioning. All of this will happen without your conscious effort, without your needing to remember or plan or try. The river teaches us this, the art of effortless action, what the Taoists call Wu Wei. The river doesn't strain to flow. It doesn't force its way through obstacles. It simply follows its nature, yielding to the landscape, filling the spaces it encounters, finding the path of least resistance. And in this yielding, in this gentle persistence, it accomplishes what no amount of force could achieve. It carves canyons. It nourishes civilizations. It shapes the very face of the planet. You, too, can flow like this. Not just in sleep, but in waking life. You can meet obstacles with flexibility rather than rigidity. You can allow yourself to be changed by your experiences, rather than resisting change. You can trust that, like a river finding its way to the sea, you will find your way through whatever challenges lie ahead. The river doesn't worry about the future. It doesn't regret the past. It exists fully in the present moment, responding to the terrain it encounters right now, in this moment, always in this moment. There is a kind of freedom in this, a kind of peace. To be like water, adaptable, persistent, nourishing, cleansing. As we come to the end of this journey, I want you to know that the river continues. Our story ends here, but the real rivers, the ones in the world, the ones in your body, flow on. The Amazon will still be discharging millions of gallons per second into the Atlantic. The Mississippi will still be carrying sediment from the Rockies to the Gulf. And the rivers in your brain will still be circulating, protecting, nourishing, cleansing. You carry within you something ancient and sacred. You carry rivers that have flowed since before you were born, that will flow until your last breath. These rivers connect you to every human who has ever lived, to every creature that has ever thought or felt or moved. We are all made of water. We are all temporary patterns in the flow, eddies in the current, waves that rise and fall and return to the great ocean. There is something profound in this realization, something that can ease the burden of existence. You are not alone. You are not separate. You are part of the water cycle, part of the great circulation that includes clouds and rain and rivers and oceans and every living thing. The same water that flowed through dinosaurs flows through you. The same water that will one day fall as rain on a future forest is, right now, circulating through your brain. Nothing is permanent except change. Nothing stays the same except the fact of flow. And this, paradoxically, is deeply comforting. You don't have to hold on so tightly. You don't have to control everything. You can release your grip, just a little, and trust that the current will carry you. Right now, as you rest here, as you breathe slowly and steadily, you are doing the most important thing a living being can do. You are maintaining yourself. You are allowing your body's natural healing processes to unfold. Sleep is not laziness or escape. Sleep is essential maintenance, as necessary as food or water. And in sleeping, in dreaming, in resting deeply, you are honoring the rivers within you, giving them space to do their vital work. So let yourself sink deeper now, if you haven't already. Let your body become heavy, supported completely by whatever surface holds you. Let your breathing slow to its own natural rhythm, like waves on a shore, rising and falling, in and out, requiring no effort, no attention. Let your mind release its hold on thoughts. Let them drift past like leaves on water, coming and going, none of them requiring your engagement. You are safe. You are held. You are exactly where you need to be. The night surrounds you like water, dark and gentle and limitless. And in this darkness, you can rest completely, knowing that the rivers within you are flowing, the ancient processes are continuing, and tomorrow, when tomorrow comes, you will rise like water vapor into the air, ready to begin another cycle, another journey. But that is tomorrow. Right now, there is only this, the soft darkness, the gentle rhythm of breath, the feeling of letting go. There is only the river, flowing endlessly, asking nothing, giving everything, showing us how to be. Let the river carry you now, all the way down, into the deepest pools of sleep, where no light penetrates, where no sound disturbs, where there is only peace, only rest, only the eternal flow of water returning to water, consciousness dissolving into the vast ocean of being. The river flows. You flow. All is flow. All is well. Rest now. Rest deeply. Let the rivers of your mind carry you home.